Hello, in today's video we're going to be talking about the idea of the mole. Now this is a very important video and a concept in your study of chemistry. So the mole is the unit that we as chemists deal with every day. So why do we have to have this new unit, this new conversion factor? Well, let's take a different example. Let's say I ask you to go to the store and buy 36 eggs. Nobody's going to say that. No parent has ever gone to their child, go run to the store and get 36 eggs. What somebody would say is, go run to the store and get 3 dozen eggs. So that dozen is a way of grouping 12 sets of things into one unit. So instead of counting 36 different times, we know that each dozen has 12, so we would only need 3 dozen. So it's a way of reducing the overall number into a manageable number. Now for eggs, it's not that big of a deal. Nobody's going to be going out and getting thousands upon thousands of eggs in their everyday life. However, for chemists, the mole is a way of grouping thousands upon thousands upon thousands of molecules and atoms and ions and all sorts of stuff that the chemist deals with in everyday life. So the idea of the mole and what it is, we're going to start by assigning a new unit and a new entity, conversion factor. And we're going to call that Avogadro's number. And that is written as a capital N subscript capital A. And what Avogadro's number is 6.022 times 10 to the 23rd. It's going to have kind of funky units right now. Entities per 1 mole. And we'll see the mole M-O-L-E and we'll see the mole M-O-L. Okay. So this is a kind of a weird unit going on here. Entities per mole. What's an entity? Well, with Avogadro's number, entities can change based on what we're talking about. Great, that's going to become a little bit more difficult as we go on, but let's see what it can be. Entities can be atoms, can be molecules, it can be formula units, also known as FU. It can be ions, it can be protons, it can be neutrons, it can be any of those types of things for counting large numbers of very small items. So atoms are super small. There are 6.022 times 10 to the 23rd atoms in 1 mole of a substance. Okay, so this still seems a little abstract right now. How can we bring this to the everyday life? Well, the mole is related to the atomic mass and the molecular weights that we've been determining. So let's go back to our concept of carbon dioxide. So we found that the molecular weight of carbon dioxide in a previous video was 44.01 AMU. Well, the AMUs are kind of useless at this point in chemistry. This AMU on the periodic table can be replaced by something that a chemist will deal with in everyday life. The AMU for the molecular weight, which we'll call molar mass now, can be replaced with grams per mole. So any atomic mass or molecular weight that you find from the periodic table, you can replace the AMU with grams per mole. Now what does this do? This allows a chemist to weigh something out in a laboratory in grams and be able to convert into our new unit of moles. Well, what does that mean to us? Why do we care? Well, once we have moles, we can then calculate the number of atoms, the number of molecules, the number of formula units for a given compound. So this becomes very, very useful to a chemist because we can actually count the number of atoms in a relatively short amount of time. So let's take an example of carbon dioxide. Let's say that I have 44.01 grams of carbon dioxide. I've weighed out 44.01 grams of carbon dioxide in laboratory. And I want to know how many molecules of carbon dioxide I have in 44.01 grams of carbon dioxide. Well, it's going to be a 2-step conversion. So what we're going to do is we want to get rid of the grams and convert it into moles. As a chemist, and in this general chemistry course, what you should always be doing is taking your mass and converting it into moles, because the unit of moles is much more interesting and much more functional for a chemist. So grams are great, we can weigh them in laboratory, but we can't do a whole lot of conversions with it. All we can do is convert it into moles. And the way we do that is we take the starting amount of the molecule, and we divide by the molar mass. 44.01 grams of CO2 for 1 mole of CO2. We found this 44.01 grams per mole on the periodic table. We weighed this 44.01 grams in laboratory. So the reason why I used the same number twice, the numerical values are the same, the units are very different, is to make it easy in my head. Okay? So 44.01 divided by 44.01 is just 1. Okay? So we can see the units of grams cancel. We're now left with moles on top, moles of CO2. But I want to know the number of molecules of CO2 that are present in 44.01 grams of CO2. So what I can do is I can multiply by Avogadro's number. For every 1 mole of CO2, there's 6.022 times 10 to the 23rd molecules of CO2. The moles of CO2 cancel, we're left with molecules of CO2. That's exactly what we're looking for. So now we have a 2-step conversion to go from grams that we weigh out in laboratory to predicting exactly how many molecules of CO2 are present. So if you were to go through and do this calculation, you would end up with 6.022 times 10 to the 23rd molecules of CO2. So what does that mean to us? That means that in 44.01 grams of carbon dioxide, there are 6 followed by 23 zeros worth of molecules within that small amount of mass. This shows that the molecules and atoms and formula units are all very, 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 very small. Right? So we have a huge number down here because we're counting something that's macroscopic big, 44.01 grams, into something that's really, really small, molecules. So this is our new understanding of this idea of the mole. The Avogadro's number is going to be useful to us. It's going to be able to convert between atoms, molecules, formula, units into this idea of the mole. And we know we can relate the mole to something macroscopic, something that we can see and feel, by using the molar mass that's found on the periodic table, which has now has units of grams per mole. So we're going to be doing lots and lots and lots of conversions with this. So this is a quick introduction into the idea of the mole. And with that, I want to say have a great night. I will see you all in class tomorrow.